The implementation of position-independent code for functions is a little different from variables. There are different trade-offs because function calls are much more common than shared data, and it turns out that in many applications the main program will import many functions from a shared library, but actually only use a few of those functions each time it's run. So it's worthwhile to lazily link the functions that are imported from the shared library, and that lazy linking is possible because we're calling a function and we can interpose on that function. So if we have this position-dependent code where we have f calling a, and a is supplied by some other shared library, this will get compiled more like a function, f, that calls a function with a funny name, a at plt. A at plt is ultimately going to call real a. But the way this is implemented to make it lazy is that real a is initialized to point into a at plt itself. So this goTo turns out not to do anything. It just goes to the next statement, which then goes to a fixup function, passing along the information that the thing that needs to be fixed up is the function a at plt. The fixup function knows that a at plt uses this variable real a, and that's the one it needs to fix. And it fixes it by installing the pointer to the function a as provided from some other shared library. So if we look at that in the elf format, that means that this code, elf calling a, is going to turn into this kind of elf file. The text segment, which has f, is going to have a call to a at plt, and the at plt is because it's in the plt section. That stands for probably procedure lookup table. That has the code that we saw for a at plt, where it jumps to some variable. The variable is going to be stored in the .got.plt section. So global offset table again, but the one for functions. Originally, and in the elf file, that just points back into the middle of the same function, which proceeds by pushing onto the stack information that it needs to fix up this particular use, a, and jumps to the fixup function that will be supplied by the OS. That fixup function knows that this relocation information says fix up that particular variable, the real a variable in our pseudo C code, so that it'll jump over to the actual actual implementation of a instead of just jumping back in here. When fixup makes that change, then future calls will call into the a at plt and then jump directly to the appropriate implementation of a. So you pay a cost on the first time that the imported function is called, but then future calls are much faster.